Welcome everyone. Today's topic for the discussion is Introduction to LTE Long-Term Evolution. As part of the agenda, let us look at the key objectives of LTE. Then we will see the various frequency bands or spectrum that is licensed to be operated by LTE networks. And then we'll discuss on various additional services that are offered by LTE networks in addition to the previous generation mobile systems, that is GSM and UMTS. And then we'll look into high level network architecture that enables offering these additional services to mobile subscribers. And finally we'll conclude the discussion by looking at security and privacy requirements. In the Introduction to 3GPP Technologies discussion video, we have seen various 3GPP technologies such as GSM, Global System for Mobile Communications, UMTS, Universal Mobile Telecommunications System, LTE, Long-Term Evolution, and 5G, and how they are advancing the world of mobile communications. Today, let us discuss about LTE, long-term evolution, which is considered as fourth generation mobile technology of 3GPP variant. LTE is an evolution from the previous generation of technology, that is UMTS, Universal Mobile Telecommunications System, which is considered as a third generation mobile system of 3GPP variant. When it comes to objectives, 3GPP system evolution is split into two parts, that is short to medium term and long term. Short to medium term evolution include improved radio performance, which includes higher spectral efficiency, improved coverage, and radio protocol optimization for shorter radio access latencies. Then support for better user equipment performance, especially in terms of power consumption. And then optimization of radio access network architecture, especially for packet data communication, to improve the efficiency of the network and to lower the implementation costs. Then harmonized IP multimedia subsystem IMS to provide the opportunity of service transparency, seamless roaming, and common applications across all evolving IMT 2000 systems. Then packet data communication optimization in the core and radio access network architectures to improve the efficiency of the network. Then enhanced user equipment with increased battery life, understandable user interfaces, larger choice of terminal models and terminal types, and support for secure download of applications. Then advances in security, establishment of USIM-centric 3GPP security mechanisms as a cornerstone for all kinds of trusted relationships, and introducing necessary state-of-the-art protection mechanism needed to cope with the increased threats due to overall IP-based network and terminal activity. When it comes to long-term evolution objectives, which are driven by market trends, understanding of user requirements, and the availability of new network and wireless access technologies. These include radio access performance improvements across spectral efficiency, higher bit rates, and shorter delays. Spectral efficiency targets include 5 to 10 bits per second per hertz in an isolated cell, while 2 to 3 bits per second per hertz in a multicellular environment. Peak data rate targets include up to 100 megabits per second in full mobility wide area deployments, while up to 1 gigabits per second in low mobility local area deployments. Then seamless integrated network comprising a variety of networking access systems connected to a common IP based network supported by a centralized mobility manager. Then interworking between 3GPP mobile network and other networks, communication service providers may complement cellular networks with a mix of technologies that could incorporate wireless local area network WLAN, digital broadcast, satellite and other access systems in order for the user to be able to receive a variety of content via a variety of delivery mechanisms depending upon the particular terminal capabilities, location and user profile. Lower cost of ownership by providing carrier grade reliability without requiring the use of high reliability platforms. Other objectives include fault tolerant networks with enhanced scalability to meet the constantly growing traffic demands. When it comes to the spectrum, these are the various bands that are being supported by long-term evolution in line with ITU advanced recommendations from International Telecommunications Union ITU. Similar to UMTS, LTE also supports both frequency division duplex and time division duplex modes. In frequency division duplex mode of operation, uplink and downlink transmissions use two separate radio frequencies, while in time division duplex mode of operation, uplink and downlink transmissions are carried over the same radio frequency but at different synchronized time intervals. Now let us look at some of the additional features that are introduced in LTE. In addition to those basic telecommunication services including bearer and teleservices and supplementary services along with network features that we have seen in 2G and 3G mobile systems. Starting with mission critical push to talk MCPTT, a push to talk service provides an arbitrated method by which two or more users may engage in communication. Users may request permission to transmit traditionally by means of a press of a button. The mission critical push to talk over LTE service supports an enhanced push to talk service suitable for mission critical scenarios based upon 3GPP evolved packet system services. Mission critical push to talk is primarily targeting to provide a professional push to talk service to public safety, transport companies, utilities or industrial and nuclear plants. Then V2X services refers to vehicle to vehicle, vehicle to infrastructure, vehicle to network and vehicle to pedestrian. The entities such as vehicles, roadside infrastructure, application server and pedestrians can collect knowledge of their local environment such as information received from other vehicles or sensor equipment in proximity to process and share that knowledge in order to provide more intelligent services such as cooperative collision warning or autonomous driving. Then public warning system. Recently there have been an interest to ensure that the public has the capability to receive timely and accurate alerts, warnings, and critical information regarding disasters and other emergencies, irrespective of what communications technologies they use, to protect their families and themselves from serious injury or loss of life or property, to enhance the reliability, resiliency, and security of warning notifications to the public by providing a mechanism to distribute warning notifications over 3GPP systems is the objective of this feature. Then mission critical video and data, which define services for mission critical communication using LTE transport networks. Mission critical refers to meeting the needs of agencies providing public safety services such as police, fire, and ambulance services. They needed high reachability, availability, and reliability of the service, low latency, real-time operating capabilities, highly secured operations, interoperability with other services and systems, private and group communications, handling of emergencies, and ability to provide prioritization, preemption, queuing, and quality of service. While the streaming of video is part of the mission critical video service, the non-real-time or offline transfer of video clips stored as a file containing video data is covered by the mission critical data service. Then machine type communications. It is a form of data communication which involves one or more entities that do not necessarily need human interaction. A service optimized for machine type communications differs from a service optimized for human to human communications. Machine type communication includes devices communicating with one or more servers and devices communicating with each other. Typical characteristics of machine type communications include low mobility, time controlled, small data transmission, infrequent mobile terminated, monitoring devices related events, secure connection, and group based connections. Then comes business communication. The capabilities to an enterprise include virtual leased line, wherein corporate networks are interconnected through next generation networks, business trunking application, wherein next generation network hosts transit capabilities between corporate networks, hosted enterprise services, which includes next generation network hosting, originating, and or terminating business communication capabilities for business communication users. Then group communication. It is independent to provide a fast and efficient mechanism to distribute the same content to multiple users in a controlled manner. Concept of group communications is used extensively in the operation of classical LAN mobile radio systems used for but not limited to public safety organizations. Then single radio voice call continuity, SRVCC. voice call continuity between IMS over packet switched access and circuit switched access for calls that are anchored in IP multimedia subsystem when the user equipment is capable of transmitting, receiving on only one of these access networks at a given time. Then circuit switch fallback CSFB in evolved packet system. The circuit switch fallback in EPS enables the provisioning of voice and other circuit switched domain services by reuse of circuit switched infrastructure when the user equipment is served by evolved Universal Terrestrial Radio Access Network EUTRAN. A circuit switch fallback enabled terminal connected to EUTRAN may use GSM Edge Radio Access Network or UMTS Terrestrial Radio Access Network to connect to the circuit switch domain. This function is only available in case EUTRAN coverage is overlapped by either GRAN coverage or UTRAN coverage. Then customized alerting tones. It is an operator specific service by which an operator enables the subscriber to customize the alerting tone which is played to the calling party. The customized alerting tone service shall override the default alerting tone towards the calling party. This service should support both audio and video. Then comes proximity based services. These are services that can be provided by 3GPP system based on user equipments being in proximity to each other. Finally, user data convergence. It is an optional concept to ensure data consistency and simplify creation of new services by providing easy access to the user data as well as to ensure the consistency of storage and data models and to have minimum impact on traffic mechanisms, reference points and protocols of network elements. Again, this is just to provide the visibility into some of the additional features that are being supported by long-term evolution LTE. Now let us look at high-level architecture of LTE, starting with user equipment. The user equipment consists of the physical equipment used by the LTE subscribers, which allows a user access to network services. The interface between the user equipment and the network is the radio interface. A user equipment can be subdivided into a number of domains, that is the UICC domain and ME domain. The ME mobile equipment domain can further be subdivided into one or more mobile termination and terminal equipment components, showing the connectivity between multiple functional groups. Then comes evolved Universal Terrestrial Radio Access Network EUTRAN. It consists of E node Bs. An E node B is a logical network component which serves one or more EUTRAN cells. An E node B can support frequency division duplex mode, time division duplex mode or dual mode operation. The E node Bs can be interconnected with each other by means of the X2 interface. The E node Bs are connected by means of the S1 interface to the evolved packet core, more specifically to the MME, Mobility Management Entity, by means of S1 MME, and to the Serving Gateway SGW by means of the S1U interface. Then evolved packet core EPC. It consists of MME, Mobility Management Entity, which is the control plane entity within evolved packet system supporting mobility management, includes non-access stratum signaling and security, inter-core network signaling for mobility between 3GPP access networks, tracking area list management, PDN gateway and serving gateway selection, SGSN selection for handovers to 2G or 3GPP access networks, roaming, authentication, bearer management functions including dedicated bearer establishment, lawful interception of signaling traffic, interworking with 3GPP circuit switch networks and 3GPP2 networks. Serving gateway. It is the gateway which terminates the interface towards evolved UTRAN. The functions of serving gateway includes local mobility anchor point for inter-eNode B handover, mobility anchoring for inter-3GPP mobility, downlink packet buffering, lawful interception, packet routing and forwarding, packet marking, event reporting, among others. Then packet data network gateway, PDN gateway, which terminates the SGI interface towards the packet data network. The packet data network gateway provides public data network connectivity to both GSM Edge Radio Access Network (GRAN), Universal Terrestrial Radio Access Network (UTRAN) only user equipments, and evolved UTRAN capable user equipments using any of EUTRAN, GRAN, or UTRAN. The PDN gateway may also provide PDN connectivity to user equipments using non-3GPP access networks. The functions of PDN gateway includes per user based packet filtering, lawful interception, UE IP address allocation, packet marking, service level charging, gating control, rate enforcement, DHCP functions, among others. Then comes policy and charging rules function, PCRF, which acts as a policy decision point for policy and charging control of service, data flows, applications, and IP bearer resources. The PCRF selects and provides the applicable policy and charging control decision to the PCEF. The policy and charging enforcement function PCEF acts as a policy enforcement point for policy and charging control of IP bearer resources located in PDN gateway. Then there are few common entities that are being used by different core networks, which include the home subscriber server HSS. It is the master database for a given user. It is the entity containing the subscription related information to support the network entities actually handling the calls and sessions. A home network may contain one or several home subscriber servers. It depends on the number of mobile subscribers, on the capacity of the equipment, and on the organization of the network. The HSS also generates user security information for mutual authentication, communication integrity check, and ciphering. The HSS also responsible to support the call control and session management entities of the different domains and subsystems. The HLR can be considered as a subset of the HSS. The Authentication Center AUC can be considered a subset of the HSS. Then the Equipment Identity Register EIR in the LTE system is the logical entity which is responsible for storing in the network the international mobile equipment identities (IMEIs) used in the LTE system. The mobile equipment may be classified as whitelisted, grey-listed and blacklisted, and therefore may be stored in three different separate lists. An equipment identity register shall as a minimum contain a whitelist. Then the subscription locator function SLF, it is queried by other 3GPP network elements to get the name of the HSS containing the required subscriber's specific data. The SLF is not required in a single HSS environment. Then we have public data network PDN. This refers to the public internet where users related services are residing. LTE, considering the packet switch based system, inherently it does not support circuit switch services such as voice and SMS. So LTE relies upon another 3GPP core network called IMS, that is IP Multimedia Subsystem, to offer these services over LTE. Voice over long-term evolution (VoLTE) is the technology being used to offer voice services over LTE networks. We will be discussing about IMS in the upcoming videos. Now let us look at the security and privacy related requirements in long-term evolution. The evolved packet system shall provide a high level of security equivalent or better than Release 7 3GPP systems. LTE shall support information authenticity between the terminal and evolved packet systems. LTE shall allow for a network to hide of internal network elements from the user equipment. The security policy shall be under the control of the home mobile network operator. LTE should provide protection against threats and attacks, including those present in the internet. The evolved packet system shall provide several appropriate levels of user privacy, including communication confidentiality, location privacy, and identity protection. The privacy of the contents, origin, and destination of a particular communication shall be protected from disclosure to unauthorized parties. The evolved packet system shall be able to hide the identities of users from unauthorized third parties. It shall be possible to provide no disclosure at any level of granularity of location related information to unauthorized parties. Thank you so much for your time. I hope you find this information useful and interesting. Please feel free to subscribe as we continue our discussion on one other 3GPP technology, that is 5G, fifth generation mobile system. In case if you have not yet gone through the previous videos wherein we discussed about GSM and UMTS, I highly recommend to watch them. Once again, thanks for your time.